Welcome everyone to this channel. Here we discuss physics problems which appeared in different competitive exams. Today's problem is from mechanics and it's a rigid body problem. It tells a ring of mass m and radius r rolls without slipping down an inclined plane starting from rest. If the center of the ring is initially at a height h, the angular velocity when the ring reaches the base is. These are the options. Okay, now in the question there is a term without slipping. It means during the motion of this ring there is no friction involved, and there are two types of motion involved. One is the translation motion and another is the rotational motion. So initially the ring was at rest, so it has only the potential energy. Now the formula for the potential energy is m, mass of the ring, g is the acceleration due to gravity, and the separation of this point from this base. If the separation of this center of the ring to this base is h and r is the radius, then this separation is h minus r. Now you can see as the ring rolls, this separation decreases. That means the potential energy decreases, and according to the conservation of energy, this potential energy should be converted to kinetic energy. Now, for a rolling motion, the kinetic energy appears from two terms. One is due to the translation motion, kinetic energy due to the translation, and another is kinetic energy due to the rotation. We know if we consider this is a point object and it has velocity v, then the kinetic energy is half mv square. So the ball keeps rolling, its potential energy decreases. Sorry, the ring keeps rolling, its potential energy decreases and kinetic energy increases. At the base, it will have the maximum kinetic energy, and there will be no potential energy. So at this point, if we consider the angular velocity is omega and the linear velocity is v, so this is the v, and the for the rotational motion this kinetic energy will be analogously this will be half I omega square, where I is the moment of inertia of this ring, and for this ring moment of inertia is very simple form, m r square. Sorry, it will be the small m, the mass of the ring. Okay, now the question asks in the form of the angular velocity, and we know this linear velocity is related to this angular velocity according to this formula v equal to omega r. So we can put it, and the equation becomes omega r whole square plus half I. Uh, then I substitute the value, the functional form of I, that will be the m r square and omega square, and finally it will be m omega square r square. Now we should equal these two energy, and it will be mg h minus r m omega square r square. So cancel out the g m, and then find it. Omega will be omega square equals to gh minus r in r square, and finally the form for omega will be under root gh minus r upon r square. So it will be the option C. So you can see that using the conservation law, uh, how easily we have solved this problem. So basically for this type of motion problem, related to motions, we need to consider the conservation of energy, sometimes conservation of linear momentum, their components. Okay, so this is fine. This type of problem repeats a lot of time in competitive exam, and sometimes we have the question just changes in the form of the object. So sometimes it is cylinder or sphere in place of ring. So so the moment of inertia formula that we need to remember for the basic objects. Okay, so hope this problem helps you, and if you have any doubt, you can, or any suggestion, you can comment in the box. Um okay, and please like and subscribe. Okay. Also share it. Thank you. Okay, take care.